In this video, we're going to derive the law of cosines. Compared to the derivation for the law of sines, this one is a little bit more involved, but that is okay. To start off, we're going to drop a vertical line from angle B that is perpendicular to the bottom line. So both of these are going to be right angles. This line is going to have length h. In the bottom line, we don't actually know how long it is, so we're going to make up another value, which is going to be x. This side length is x, making this side b minus x. Okay, because both of these triangles are right triangles, we can use Pythagorean Theorem. We're going to do that on the left side first. So we have a squared plus b squared equals c squared. Just for reference, it's not the actual name of the values. In our case, we have x squared plus h squared equals c squared. All right. We have a little bit, both of these values we actually made up, so our goal is to basically get rid of those over time. We can start by trying to find the cosine of angle A. Cosine of angle A is equal to adjacent over hypotenuse. We'll multiply this across, and we get c cosine of A equals x. Okay, cool. We're actually going to take this, copy it, and then save it over here. We're also going to plug it back into this function. So we're going to have c cosine A squared plus h squared equals c squared. We'll multiply this out. Okay. Now what we want to do is we want to get this value in isolation. So let's bring the values to the other side, and I'll move up here a little bit. H squared equals c squared minus c squared cosine squared A. Both of these have a c squared in them, so what we're going to do is pull that out. C squared times 1 minus cosine squared A. Then we're going to take the square root of both sides. H equals, it's going to be c square root of 1 minus cosine squared A. Alright, so this is the second value that we are going to need later on. Now, what we're going to do is we're going to look at this triangle. And we're also going to use Pythagorean Theorem. A squared plus b squared equals c squared. But in this case, we have h squared plus b minus x on the bottom squared equals a squared. So I know our letters are getting a little bit mixed up, but a in this case is the hypotenuse, so that's going to go on the right side. Now we're going to expand this portion. So we're going to have plus b squared minus 2bx plus x squared equals a squared. Now we're going to take the two values that we derived on the other side and plug them in. So this is going to be c radical 1 minus cosine squared A squared plus b squared minus 2b, replace x with c cosine A plus, move over a little bit, c cosine A squared, all this, equals a squared. Alright, we're in the final stretch. We'll multiply this out, c squared times 1 minus cosine squared A, so this cancels out the radical, plus b squared minus 2bc cosine A plus c squared cosine squared A equals A squared. Multiply this back in, c squared minus c squared cosine squared A and what we can see is that we have these two terms that will cancel out. So boom, boom. And what we're left with, we're going to flip around. A squared equals b squared plus c squared minus 2bc cosine A. And that is the law of cosines.